Welcome to Microsoft Virtual Academy, Windows Security and Forensic class, Module 4. In this module, I'm going to have Raymond Comvalius with me. Probably you know Raymond. In our first MVA, which I recorded at Milad, he was one of the moderators, supporting us from Netherlands. Besides that, I've done many Tech at Ignite sessions with him.
Yes.
Raymond, who are you? Can you please introduce yourself quickly?
My name is Raymond Comvalius. I am a certified trainer and consultant from the Netherlands. I usually do a lot of consultancy gigs with large companies where I help implementing Microsoft technology. And of course, I am a speaker on multiple conferences, nationally and internationally, together with Erdal, among others.
All right, perfect. So what are we going to cover in this session? I think we know the module. This module is the Windows Forensics module. And we are going to cover what is digital forensics, why do we need digital forensics, what types of digital forensic analysis is there. We will cover incident response, hash values, how we can get forensic images, how we can do forensic analysis, and what is really important in Windows that you need to know with examples from real life. All right, digital forensics. What is it? We did talk about it in Module 1 with Hasain together. So it's still the same, nothing has changed. There are different types of forensic requests, like intrusion analysis, damage assessment, suspects examination, tool analysis, log file analysis, evidence search. So I think the name is telling on what it is, how it works. But when we come to this, it's really important to understand what's going on. Raymond, can you please give us some examples here?
Well, of course, the first thing that you have to know, if something is going on, you have to know what has actually happened. So where did the intruder come from? Where did the intrusion come from? What actually happened? Before you start throwing away all sorts of stuff and moving around your stuff and trying to fix things that may have been broken, you have to actually know what is really going on your systems. And if you have any idea of what is going on, then you can make a plan to find out what did they actually do, when did it happen. Make sure that you know why did they do it the way they did it, and did they find a weak spot. And the thing here is that you have to know what your infrastructure actually looks like before you know how they
which we covered with Hasain already, right?
Yes.
So digital forensics has lots of processes, and it all starts with evidence preservation. Then you have to accuse the evidence, you have to examine the evidence, you have to analyze the evidence, and it all comes to the reporting.
Okay, if you say that, then it's really important in the beginning that you're not trying to fix things while you're removing all the evidence.
Yes, that's why usually in forensic is not fixing things anyway, but probably you mentioned this from the security perspective, right?
Yeah.
Where we fix things, or as Hasain mentioned in the previous session, we can use this in different aspects, but if we're gonna use in in code, then we won't fix things. It's not our job. But if it's an attack and you are the security expert, it's a bit different. Okay, incident response. How is incident response happening? First of all, you have to plan and identify the job roles. The incident response team should be able to initiate, record, and evaluate and analyze the findings. He or she has to be able to look at what is contained. If possible, mitigate, identify. Now, this is not forensics, right? Escalate the issue, recover, review, and most of the time, we usually do lessons learned. But as we all know, or as you should know, forensics and incident response are two separate teams which work together. All right, first responder. What is a first responder?
Well, the first responder is the one who is entering the scene, the crime scene. And that's the one who has to make sure that he clears up the crime scene in a way that nobody can enter there, that nobody can take away the traces that are there. And then you can start your investigation. So it's like the policemen will come with their stuff to make sure that nobody can enter the crime scene.
This brings us back to the slide deck, okay? If you look in the acquisition, we have our desktops, laptops, servers, tablets, smartphones, network, and the cloud. So incidents could happen in any of these. And it's our job to be able to look into the flash memories, maybe phone, disks, faxes, printers, so anything which might have traces, including my band 2, which I love, which is just came out and I love it, you know. To be honest, I didn't put my hands into it now, but I'm curious what it's held before it's been transmitted. Why? It could be someone get killed, right? And they have GPS enabled, and me as forensic examiner, I should be able to see where this innocent went and how I can get information from this.
Yeah.
So, what if the system is shut down? Then the life is easy. What we will do is we can just take an image of the hard drive. We can either boot the computer. From there we can get the system state reports. We can get the working processes. We can see what ports are open. If necessary, we can take an image of the RAM, capture the network traffic, which will make our life a bit easier. So, what is the incident response? This is my old Windows 98 or NT4 desktop. I use it all for a reason. You can see icons, you can see executed applications, you can see the system tray, which will give us lots of information. In the incident response, if the system is working, it's much easier to get the system report and see the working processes, open ports, or where we can capture the drives. And this brings me to my first demo. And here, I'm going to drive image hard drive. For that, remember in the first session when I had Hasain, I showed you our disk imaging tools. I'm gonna plug one in, and I'm gonna show you quickly how we can do that. For that, I'm switching to my demo machine. All right, here you will see that I'm just going to my software, selecting my image disk. I'm selecting the image location, and you know, you can just go select the hard drive that you want the image. In this case, the USB to make it faster, and I name it as USB drive, forensic image, active finish. It will take some time, and I will be able to get a quick image of my memory stick. Why do we need that? Because in a court case, I'm not allowed to be used in the, for example, here's my image, live image. I should be able to duplicate that, then do my analysis on it. That's rule number 1.
You have to make sure that you make no changes to the evidence.
Yes, exactly. Otherwise, I can't use it in the court. This will bring me to my second demo. If you remember, together with Hasain, we showed what is inside the RAM. How can we dump RAM images live? But in this case, I'm going to show you how we can duplicate the RAM via software. For this, I'm using my imaging tool. Let's go back to my demo machine. All right, I'm opening my software. Go to my tools. As you can see, I selected RAM. I include the steps there. I get the RAM image, and that's that easy. If your name is not Hasain Dubouf, then this is the easier way for you to capture the RAM. Of course, you need to have the software and the admin tools, and most of the time you are not able to install some stuff to the hard drive as well, right? But you can use some portable tools, or what you can do is remember, once you're imaging the RAM, you can just work on it easily. And again, this will take some time, but I think you understand the process. This brings us to another important topic, dear Raymond.
Yes.
So now, how can I verify this hard drive or RAM image is the same image that you took? Because the lawyers at court is going to make your life hard. They're going to say, hey, this has changed, this has changed, this is not belonging to this. How can you prove in a court case that the RAM image is the image that you took originally?
Well, I think you have to record every step you take.
Yeah. And what else you do?
Keep a log.
And
take the hashes, I think.
Hashes, right? Why? Because hashes are the easiest way to be able to verify. So hashes, even when you download some software from Microsoft, from MSDN, what happens? They usually give the hash number.
Yes.
To be able to prove it to you that, hey, that's what we gave you. If you download something and the hash is different, it could be man-in-the-middle attack that someone is injecting maybe something to your traffic. So that's why it's important to understand hashes. So can you please tell us what the hash value is?
Oh, the hash value is actually, it's kind of a fingerprint of your files. Every file has certain content, and when you create a hash, this is the unique value that's related to the current contents of that file. If you change a single bit, the hash will completely change. So there is always a way to tell that this has been the original file because of the hash that you took at the time that you found it.
So hashing could be via MD5 or SHA-1. It's basically an evidence. Now, if you check the slide, here I explained, you can see here the acquisition hash and the verification hash, which both of them are same, which proves that nothing has changed. The MD5, it's a message digit algorithm, which is an algorithm. It's used to verify data integrity, and it's using 120K bit message digits from data input that's claimed to be unique to a specific data fingerprint and to a specific individual. SHA, which is the secure hash algorithm, is one of the most common used cryptographic hash function. It's designed here in the States and published as a government standard.
So how do you create the hashes?
All right. Do you have I think we got a demo for that?
Well, the funny thing is that Windows doesn't have anything easy to show the hashes.
Yes, you're right.
Built in. But there is Powershell. And there is a group of people, especially they call themselves the Powershell community, who created the Powershell community extensions, and they created a function for that. It's just as simple as that. And I will show you that now in a short demo.
Yes.
Because all you have to do is download the PowerShell community extensions. I have a link for that later in the deck. And if you have that on your system, I can import the module for the PowerShell community extensions. See if it happens here. And after you have imported the module, then there's just a very easy thing. Usually you just do it there to show your files. Let's show my sysinternals folder, which shows the files that I have in that folder. And if I output the contents of that folder to the get hash command, then I will just get the hashes for all those files. So I can send the output to the get hash command. And then the output looks like this, and those are the MD5 hashes for those files.
So I don't have to install any third-party tool.
No.
It's inbuilt in PowerShell, thanks to the community.
Exactly.
And this quickly verifies that what was been taken and what it is. So Thank you. It was a cool demo. And to be very honest, while we were preparing this course, I didn't even know about this extension where Raymond made this clear to me. So even we are here to teach you something. I'm learning myself as well, thanks to my partners Hasain and Raymond. All right. Now we got the image.
Yes.
What can we have to do the analysis? So Windows forensic analysis includes file signatures, extensions, attributes. We have our file system properties. We have our operating system installation, the date, the time. We have a process baseline. And we have the logs where we can see when people logged in, logged out, shut down, password has changed. But how can we see all this? What are the common imaging formats in forensics?
Well, you have to preserve your image, the images of your hard drive. So yes, you have stuff like ISO, VHD, VMX, and all sorts of other image formats that you can use as a drive. You can use as an exact copy of the drive to show you what the drive looked like at the moment you started your investigation.
Which is cool. We can use also many different software. Again, to be honest, I'm not recommending any of these. They are all commercial software. You can just buy the one that you like. There are some, I think, open source one as well. And you can see the free ones here. FTK Imager, NCase Imager, Forensic Imager from Get Data, TechPad Reddit Pro Discover. They are the free ones. Please go ahead. And the best one, probably you notice at the very right, is this to VHD from SysInternals, Microsoft, which will help you also to get disk as VHD. I mean, I used to use this tool when virtualization was started to get popular. I used to, get my computer, image it, and share it across. But this is also perfect forensic tool, which can be used.
Yeah, and the easy thing is you can easily mount a VHD, and you can easily mount it as a read-only disk. So then you have this image that is guaranteed without any change.
All right. I just spoke about already what Windows forensic analysis requires, right? So the important things here, we should be able to see the logs. Forensics or Windows, it's all about registry. We should be able to browse the registry, prefetch the files. Could be a printer, could be a shortcut to the links, but everything is kept in Windows for us to be able to look into it. It's also important to look at the restore points, the VSS copies, the TOMDB files, recycle bin, unallocated clusters, and emails. These are usually the files that we look into it.
Yeah, but all those areas, some of those areas actually they contain historic information in themselves. But others are dynamic. And for those dynamic parts, I recommend that you create a baseline, that you know how these historically looked like. So, for instance, your processes, what are the processes that have originally been running on all your systems? So that will make it much easier for you to recognize if anything irregular is going on, if any new processes start occurring on a certain moment, if you have those baseline logs available.
All right. When we say Windows forensic analysis, as you said, some stuff are dynamic. Some file extension can be changed, some file properties can be changed, maybe some stuff will be deleted. If you remember, we did mention it with Hasain, when some things get deleted, it will just be unmarked to be ready to be overwritten. Even if you overwrite it, you can use some tools to get the data from both things. File names can be changed, file can be encrypted, but all these are really not that to worry. If you have a proper forensic software dongle, plug it in, you can really get lots of data out to investigate. All right, why is this important? Because we know that files can be manipulated. I mean, Hasain done really some great demos. And he showed that how easy we can get access. Yes, we didn't show maybe how we can manipulate a file, but for this I'm going to recommend my previous MVA again. Please go ahead and watch it. I showed that how you can create a virus, how you can combine a virus with a legitimate exe file and make it as compile it as one and send it across, which we had also in our TechEd sessions.
In that case, it's handy if you have a historic overview of your hashes. So that will make you aware of any changes that are taking place in your file system that you don't know of. Because currently that's a little bit harder because you regularly have updates of your files. But you know when the update has taken place and when certain hashes are about to change. If a hash is changing on a moment that cannot be explained because of an update being installed, that's the moment you have to be aware that something might have gone wrong. And that you have to look into the reason of the changes of the hashes of those files.
Now, I'm gonna come to another point. PowerShell. I mean, after watching Hasain's session, probably you're gonna be scared using PowerShell, but no. There is nothing to be scared. Why? Because Hasain showed you how people can abuse it. Now, Raymond, can you please show our Virtual Academy students how PowerShell can be used for forensics, how you can create XMLs, how you can get details of the files, and you already showcased how we can create hashes, but maybe you have some extra things to show us. Raymond?
Well, yes, the nice thing about PowerShell is that it's all object-based. So if you do a simple thing with PowerShell like doing a dir to show the files in a folder, it shows you the files in the folder, but what actually comes back here are objects, rich objects with a lot of information. And what you can do, for instance, if you want to make sure that you have a baseline of what your file system looks like, well, you can do something like this. Dir of the C drive, and then make sure you do it recursive, so that you have a directory of every file on your C drive. Then you can export what comes back, because when I enter now, I will get a whole shipload of what's on my C drive. It will be a lot. But I can export it. I can export it to an XML, I can export it to a CSV file or to a text file. XML is mostly one of the easiest ones. And if I created this XML file, I can use the XML file as the complete output of this command. Well, just to make sure that I have a small XML file here, let's do it like this. I will create an XML file of the contents of my sysinternals folder, and I'm going to pipe the output to my demo folder like this. I'll pipe it and export an XML file to the demo. That's not D, it's cdemo sysinternals.xml. So when I do this, you would think that it will just be like this in that file, c/sysinternals. But there is a lot more in here, and I can show it like this. I can show you like this. I can say, well, I have a variable, the sysinternals files, that equals the import of the XML that I just created. It's the demo, cdemo. I don't know where I'm at. Cdemo. Something is going wrong here.
Can happen. We're humans. We make mistakes.
Cdemo sysinternals XML. And when I'm going to look into the contents of this, I can do something like this. Look at it, and then tell me what's in here. For instance, give me the file that looks like this. Oops. And show me everything that's in there. And now you see that it's not just the autoruns file that it shows the autoruns file and it shows every property of the autoruns file, because the object is much richer than just the file name. It's the file and everything there is to know about this file. So you see all the version info in here, and you see everything about when it's created, when it was accessed, everything, when it was written, and its archive. This information does not contain the hash. So if you want to have the hash on this file, you also have to use the get hash, command to create the hashes for all these files. But this way you can have an overview of an historic overview of every file in your system created by Powershell.
Cool. This brings us to the next point. So now we have a baseline. Why? Because we know things are changing in a computer, right? We might have someone formatting the computer, installing some stuff. What about, is there any PowerShell component where we compare running processes? Like get process, can you do the demo? I mean, I got the script.
Yeah, we can
here.
do the same thing with processes. And the nice thing is that you cannot just get an overview of all your processes and all the properties of the processes, but you can also start comparing stuff. So for instance, let me show you this in my short demo. If I use get process, it will show me just all the processes that are running on my system. This is easy. But I can output this, like this, get process.
Export CLI.
And then export it to my demo folder and call it process1.xml.
You can name it whatever you like. Just
for clearness, I named it process1.xml. Now, I am creating an XML file that contains all my currently running processes. Now, when I make a change to my running processes on my system and I create a new XML file, this new XML file will contain the new set of running processes. Now, and how do I easily find the differences between the first one and the second one?
Via comparing them?
Yes.
So you should be able to get a compare object command and get the first process and second process and run the PowerShell hopefully to be able to grab this for me.
Yeah, for instance, I'm now starting Notepad just as an example. And when I now create a new XML file, I have two XML files, and one has Notepad in it, and one doesn't have Notepad in it. And how should I find out about this?
Can you show me the details? Maybe we get process details, and we process it out, print it out. Can you do that for me?
Well, we shouldn't print them out. The easy way is just use PowerShell.
Screen, I mean.
Just use PowerShell. PowerShell has a command that says compare object. And what you can do is make sure that you have two objects, one with the first set of processes and one with the second set of processes. So what I'll do is I'll create one with the first set of processes, which has the import of cdemo 1. Something is going wrong here. I did the wrong command. No, there is an error in my command, but I lost my cursor for some reason, so.
Yeah, it's okay, no problem.
Like this. And I have the second set. And
perfect.
And now I can start comparing these. So I can do something like this, compare
Object.
object for process 1 and compare it to process 2.
Property.
On the property
Process name.
process name, exactly.
And
now it
it's
tells me
Notepad.
there is one difference between those two sets of processes. It's Notepad.
So I don't have to open the files and go
Nope.
through the list and say, okay, that's not so.
No, so-
PowerShell is doing this to me.
So what you can do, for instance, is that you regularly create a job that does the export for you to a central folder. And then once in a while you check if the contents of the running process is the same as it was before.
And maybe it doesn't make that much sense when we show it to you with a notepad, but think about a computer which has hundreds of applications installed before and after. This is a very handy tool. Do you have to really know PowerShell? Is there not something inbuilt which Windows showed to me? If you check quickly my slide deck, you will see that Windows 10 has something which can show all this to me as well. What is it called, Raymond?
Yeah, there is this reliability history. And this is something that was actually introduced in Windows, I think in Windows Vista even.
I think, yeah.
It's been there for a while. and
2008, I think 2008 or 2000. I don't remember, but
well, Vista was there before 2008.
okay. Yeah.
But
it came together in the same code.
But it's actually here. It's here in your control panel, and it has always. This is valuable information for everyone because you know the standard answer of anyone who you are asking what did you do with your system when something goes wrong is I did nothing. Nothing has changed. I don't know anything about what happened. But with the reliability history, you have hard evidence in your hands, and it's as easy as it. I'll show you. You go to the control panel. Look for reliability and you say view reliability history. And then it's creating a report for you. And the report is showing that my system is hasn't been very stable for the last period of time.
I guess why. That's for our next demo, I guess.
Probably. But what you see here is that it shows you per date what happened, shows you critical events of applications that crashed, and it shows you informational events of installations that you did. And that's for the date historically. So if you see that your system suddenly starts behaving different, like on this date that I did something, and you see that the reliability of your system suddenly drops, you can tell what happened on that date. And it will show me here that I did a couple of software updates. And after those software updates, something probably went wrong. Or maybe it was the day after that something went wrong. Well, I think it was this day. That I installed a number of applications and drivers that made things not work so well anymore. So this is also a very good way to see what has actually happened to your systems historically. And why have the stability of your systems changed.
Cool. All right. This brings us to the other topic then. So I said people log in, log out, and this will just have everything, right? So, of course, this can't be used in a forensic matter. For that, we have to have access to the logs. And when I say logs, this is usually the system event logs, security event logs, applications, setup, PowerShell. Now we understand why we have logs for PowerShell. I mean, Hasain's and Raymond's two demos is a really good setup. Also, your hardware logs, your other event logs are here important to view as well. I mean, you can use also PowerShell to get these logs. We can just use the commands that you can on the screen.
Yeah.
And you can just get the output. But there is also one other thing which is important. If you remember, in the very beginning, we were talking about registry.
Yeah.
So I think this is obvious. Everybody know how to use registry. We can just go to track edit. And that's not my system, sorry. The system hives didn't change. It's still same. You can see the HK classes root, current user, local machine users, current config, which will have the sources that we need for forensic analysis. What is a prefetch file? How can we use prefetch file, Raymond?
I have no idea. Tell me.
Okay, Microsoft created a prefetch cache to improve boot and application launch time. What it does is, via caching the commonly used applications, the operating system, in this case Windows 10, can determine what is used by systems resources or how is Windows accessing the application. When the application launch up, we can see if there is any update, and this will be in C Windows prefetch file where everything is held and the extension will be PF. So it's basically a way for us to be able to view what is going on in our computer. And us forensics experts will look into these files to be able to see what has changed during booting. Could be a rootkit, could be some sort of application which was manipulated.
Okay, now I know where you're heading at. So this prefetch mechanism was there to speed up the boot for Windows.
Exactly.
And what it did is it tried to predict what you were planning to do after you booted your system. So it preloaded everything, so that if you clicked Word, for instance, every time after you booted, it had preloaded Word, so that it was there in a snap. And now you use the contents for your forensic analysis. So if Word has changed, then the cache became invalid, and you know something has changed.
Exactly.
Okay.
Perfect example. Thank you. This can be also replicated in printers, printer spooling. Why? Because might be someone done something and they're printing, or it could be a letter which was sent out, you know, Raymond, I'm going to kill you. Print it out, I send it to you by email. We can, you know, look into the spool printer folder in our computer to see if I really wrote this and printed from my computer. For that, all what you have to do is go to System, 32 spool printers folder, and you can see the spool data in the SPL files, or the .sht files are the shadow files contain the job settings, which gives us proof. What else can be done? Spooler files. For that, you can go and download the free splweave.exe from the website, which will be able to show you what was printed and when and how. So it will give you lots of information, and in this case, if I send you this letter, this is a good proof that it was printed from my computer.
Well, this is something that you can find in Windows, but you will usually find the backup of your evidence in the printer itself. Because lots of printers have hard drives in there that actually contain, the large network printers have hard drive in there, and that contains every letter that has ever been printed on that printer.
Well, the only issue with that, in terms of forensics, hard drives in big printers, in a very common environment, it's commonly, not commonly, continuously overwritten. And this can, you know, if you're gonna do forensic analysis, unless you have the hardware forensic analyzers, it's really hard to get the data because the file is being continuously overwritten, which will maybe bring the quality down in terms of restoring the data that you're after. But you're right, it's also a way of getting it out.
Okay.
After that, we should be able to know how Windows works. Windows usually creates shortcut file links, which we call info2, which contains records that are corresponded to each deleted files in the recycle bin. It has a record number, it has the drive designator, it has a stamp with the time on it, and how and when it was moved to the recycle bin. Of course, it's going to have the file size, the original name, full path, and the ASCII or Unicode information. Every file which is sent to recycle bin are maintained according to the specific naming convention. In this case, D, the original drive letter, could be C or A, Z, sorry, this is America, number and dot original extension. This will be a way to see. Raymond?
Is this also true for the files that you have deleted from the recycle bin?
Yes, don't forget, when you delete it from recycle bin, it's not actually deleted. It's just been marked for overwrite. I mean, I know I repeated this before, but in reality, don't delete that. And even if you defragment your computer, which you recommend unless you're using SSD hard drives, the clusters software can easily, or hardware can easily see what you have done. Now, I want to mention the restore points. We're doing forensics here, right? The volume shadow copy. Restore points are created to allow us, the users, to have different choices in the system state. What happened? Remember, I think since Windows XP there, if you do something wrong, you can just go to previous restore point, which you can just get rid of what you have done after that restored point. System restore has an automatic restore point, a space management feature that usually deletes all the old restore points to make room to the new ones, and you can set this easily up. But for me, as a forensic analyzer, it is really important that I know what has been there. In a VM environment, and Hyper-V or other competitors, it's easy. You have the snapshot, and you will be able to see the snapshot details, which will log. But in Windows, it's not been really logged. But you should be able, as a forensic analyzer, to suspect that, hey, there must be something happen. Or, you probably notice when you install a Windows update, when you install a new software, Windows will automatically create a system point.
Yeah.
But some people can misuse this, and they can do some misbehavioral action. Go to the previous system point,
Restore point. Yeah.
and there you, as a forensic analyzer, you might have to see what has been done, because the smart suspect will not be able to think that it can be seen what has been done. And I got a real case example for this, which I'm going to talk later. Where are they stored? Let's quickly have a look on our slide. If you go to see system volume information, you will see all restore points here. And what if it was been full and been deleted? Doesn't matter. Here's my forensic tool, which you can restore everything from the hard drive. And more importantly, you can only get the differences as well. For that, here's the software. I just plug it in. It's in a dongle. I plug it in, and it will automatically sort it out for me. It's like your Powershell, and it's quite useful, which I'm going to show in a next demo.
That's very cool.
All right. What is the thumb.db files?
This is the thumb files, the thumbnails of your pictures.
Yes, of the images in any folder. Usually, you have OLE embedded data present in the thumbs file, and in many cases, the images probably been deleted from the directory, but hey, they are still sitting in the cache where if you're doing something illegal and the police comes and investigates your computer, that's where they find it. So I'm not telling you, hey, do illegal stuff and police, but I'm telling you, everything has been traced, and thanks God, Windows is built in a way that it's in a good way and a bad way. In a good way, you can just get everything bad. In a bad way, if you do something bad, it's been logged, which gives us, the administrators, the security experts, way to gain all this information.
So the thumbnail cache may contain information of files that you once had, and that are no longer there on your system.
Yes. So a few minutes ago, we talked about fragmentation. What about unallocated clusters, slack spaces? The unallocated space or free space are usually in a hard drive the free space which is not used. by the storage or by volume. Unallocated clusters can be valuable source of evidence in a computer forensics examination. Why? Because they can contain many deleted files. Remember? It's been unticked to or written, but they're still there. And a computer user can use it anytime when the computer decides to write it. Slack space, on the other hand, is the unused space in the last cluster of a file where the logical size of the file does not fill the complete cluster. The file slack can contain fragments of all data previously stored in that cluster.
Okay, but a smart user can have used software that erased all the traces of these.
Of course, for this,
spaces.
in the module 1, as you remember, we had disk erasers. A good way. So now I want to give a real case example, which happened. I want to send my greetings to Shukri Durmaz, a friend of mine, master in forensics. Okay, to be honest, he was leading the case. I was just there with him. What happened is, me and Shukri were invited in a very big retail store. They called us, and the whole system was down. They couldn't sell anything, and it took, for the first 6 hours of the day, they could not sell anything to their customers, and it was a disaster. Anyway, from backup, they restored it back, but the management decided to do a forensic investigation and find out what happened. So, for us, we were not sure. We were there under Shukri's supervision to see if it was an unauthorized access or a data sabotage. So we know that there is a SQL database, and we found out that the admin password was deleted and all user permissions were cleared. So someone has information. And to protect the privacy of the case, that's what we first asked. Does anybody knows that we're coming there? When we found out that nobody knew from the admin team that we were invited to do the investigation, we took our tool set, we went there. Of course, first we imagined everything to make sure. But hey, we had 20 administrators. Okay? Who did done this? So if you're gonna take image of 20 computers and do full analysis, it will take days and days and days. A, probably budget is gonna be too expensive. B, I don't want to spend 40 days in a case to find out. So what have we done? Based on what happened, Shukri suspected it was an insider. We split into two. We started to interview the administrators. What happened? Based on the behavior, one of them were very suspicious because when they found out we were there, one of the suspects started to say, "Hey, can you restore anything?" We said yes. "Can you see deleted logs?" We said yes. He started to ask funny questions. I reported this to Shukri. He said, "Okay, this is not a case. I mean, this is not a proof. But what we can do is we can start to investigate from this computer." Why? Because he's the suspicious one. When we looked, I think I got it on the slides as well. We had 20 computers, one server, one RAM image, and we have to analyze all of this in a very short time. Where are we going to start? As I said, we had one suspicious person, and how there is Edmund Lockhart. He is the father of forensics, okay? He has a core principle which says a crime cannot occur without leaving a trace. So with contact between two items, there will be an exchange. Let's say you go, it's Seattle, right? We are in Seattle here. I don't know where you're watching this session, but we are in Seattle. It rains all the time. you might have a boot, you press on the mud, you step in the mud. If you step in the mud will have your footprint, and your boot is gonna have some mud. So there will be an exchange between two items. If I hit you there, Raymond, so you're gonna have a red mark in your skin, and you're gonna be in pain, and I'm gonna feel while I'm hitting you your skin. So two-way. Okay, this was not the best example. But what have we done? We found out that some sort of logs were deleted only from one computer. Then you remember the user came and asked, did you delete the logs? When we could use Powershell as well. Then we used our forensic software. We found out that only one computer had huge gaps between the logs. Okay, we could continue to be honest, I started to continue to do the forensics, but then Shukri started to interview the second files. Okay, after a little while, we found out that the person who was suspicious, that, you know, after saying, hey, we have all the traces, we done a keyword search, we looked in the SQL logs, we looked in the log recoveries, we checked the event date, the time chart, the installed software, and we found out that only one computer was different to the rest 19. And right after 30 minutes, we were able to see that that suspicious guy done some search in his computer. He went to his favorite search engine, and this is a proof that he searched how to earth SQL Server logs. But again, this could be, you know, done in any other date. This gave us some suspicious, this gives more proof to the suspicions, right? Then we found that he downloaded some scripts, and he executed the scripts, and he changed it, but he deleted the scripts as well. We found proof that the deleted scripts were still in his computer. What else? We were able to see that he didn't just delete the logs, he didn't just done a Bing search, he didn't just download the script, he also had an Excel, which was deleted, file of all the wages of any other employees. When I reported this to Shukri, he went to the IT manager and he spoke to him, said, hey, did anybody ask for salary increase? And guess what? It was that one suspicious person who wanted the salary increase as well. After the final investigation, he admitted what he had done. But they did not take this issue to the court because it was a huge company. Of course, they break the contract with the employee, but they let him go. He was lucky because he could pay for all our services, which I can assure it wasn't free. And in the previous sessions, Hasain was here as well. I know he has many other similar cases. So, back to forensics. It can be done what happened is, unauthorized access, data sabotage was done there. The Excel sheet was there. And when we looked into the emails, we also find out, by the way, that he sent someone an email saying the company didn't pay what I deserve, and I gave them some hard time. More importantly, he was making fun of his actions. So he thought sending an email and deleting the email is not going to give us access. He thought deleting some files is not going to give us access. Yes, we were lucky. We had Shukri with us, who was really experienced and who done more than 3,000 forensics cases. Okay, even though I used to teach forensic classes. Forensic is a different expertise area. I'm still here teaching forensics, but you need really to have your sixth sense very powerful to be able to sniff. You have to be the wolf, like I was saying, to smell where the attack is coming from and to be able to have something into it. Anyway, I think we spoke too much. We are a bit over time as well.
Yes.
Let's summarize it.
So what you're saying is that for real good forensics is a matter of experience.
That's rule number one. But you have to start. This is a perfect start for you. We had some level 100, 200, and 300, and some 400 examples here. Please, don't just watch 7 videos and think you're a forensic expert. Take your time, look into it deeply, read, and don't forget. I mean, everything has been logged. It's like, think about your child when they were little. You let them run between an area that you can see. If they cross this area, you either call them and slow them down. So this is what it is. We finished just module 4. Me and Raymond, we're gonna be back with module 5, network forensics. Continue watching us. Thank you very much.
Thank you.